Okay, we're going to have a look at matrix multiplication. There's two types of matrix multiplication. One is scalar multiplication, and the other is matrix by matrix multiplication. This is an example of matrix by matrix multiplication. This is much more advanced than addition and subtraction of matrices. It works on what seems to be a little bit of a convoluted process at first, but it is something that you get the hang of pretty quickly with a little bit of practice. It's just very different than what you would expect when you go into this process. So let's talk about if matrices can be multiplied by each other or not, if you can take two matrices and multiply them. This is predicated upon what I call the inner-outer rule. Okay, the inner-outer rule works like this. It's very wordy to start out, but when I draw the little organizer for it, all the words seem to disappear, and the efficiency of the organizer kind of kicks in and takes over. So let's see. The first part of it is you can do the multiplication when the number of columns of A is equal to the number of rows of B. This is what we call the inner part of the rule. Again, it's very wordy. What I draw for it in a second is going to take the place of this wordiness. So the next part of it is the size of the answer matrix will be the number of the rows of A by the number of the columns of B. Well, that's very wordy for this little trick that I'm going to show you right here. If we're asked to multiply these two matrices, we are given a 2 by 2 matrix and another 2 by 2 matrix, and I write those sizes side by side. And what I do is I look at the inner numbers. This is what we call the inner part of the inner-outer rule. If they're the same, I can multiply the matrices together, so I just note it with a little y for yes. And then I look at the outer numbers, in this case also 2 by 2, and that will tell me the size of the answer. So I'm going to draw a 2 by 2 matrix here that's pretty sizable too. To start, I'm going to put these little dots in it that kind of just tell me a little bit about where the entries will go in this 2 by 2 matrix. Okay? Now, one of the things you want to become accustomed to is being able to state where these dots are in this matrix by using words such as top and left and bottom and left, or bottom and right and top and right. So up here we would have the top left entry. This would be the top right entry. This would be the bottom left entry. And this would be the bottom right entry. Now, why do you need that? Well, it's because to make this top left entry, you're going to use the top row of the first matrix and this left column of the second matrix. Similarly, for this bottom right entry, you're going to use the bottom row of the first matrix and the right column of the second matrix. Again, it's a little bit of a convoluted process, so I'm going to get into modeling it right now, and maybe you'll get a better understanding of it. Okay? So, for starters, let's talk about finding the top left entry in the answer matrix here. So what I'm going to do is I'm going to use these little organizers, and I'm going to use the top row of the first matrix and the left column of the second matrix. Well, what I do is I multiply the corresponding elements of each row or column together and add the results together. So what I'm just going to do here with the shapes is I'll multiply same shapes and add the results of those multiplications. So in red, we've got 4 times negative 2 plus, and in blue, we have 1 times 5. Okay? And then to get the top right entry, I'll again use the top row, but now I'm going to use the right column. And again, I'll match shapes and do multiplication and add the results. So that's going to be 4 times 6 plus 1 times 1. And continuing on, if you're getting the hang of it, to do the bottom left entry, I'm going to use the bottom row of the first matrix and the left column of the second matrix. So again, I'm going to do 3 times negative 2 plus negative 6 times 5. And lastly, I'm going to do the bottom right by doing the bottom row with the right column. And you'll see that's going to get me 3 times 6 plus negative 6 times 1. Now, short of simplifying, that's really it. So I'm going to actually simplify now, simplify over here for the sake of space. And I'm going to get in the top left, I'm going to get negative 8 plus 5, which is negative 3. Then I'm going to get 24 plus 1 is 25 in the top right corner. And then the bottom left, I'm going to get negative 6 plus negative 30 is negative 36. And then in the bottom right corner, I'm going to get 18 plus negative 6 is 12. And that is my 2 by 2 matrix, which is the product of these two matrices that I have given here. So again, the inner-outer rule helps us determine if the two matrices can be multiplied, then determines the size of the answer matrix that it will yield when you do that multiplication. Okay? And what you want to do is look to the answer matrix for where you want to put a particular entry and have that dictate which rows and columns you will use in the combination to create that entry. So feel free to watch this a couple more times. You can practice on your own and check them on your calculator.